Thanks for the warm invitation and the introduction. Hi, everyone. Welcome to this last session of the day. Hope you had a great day at JCon. I want to finish up with a, let's say, rather soft topic today, how we can do and perform Agile architecture and Agile projects. So I'm going to show you quite a few tools that have proven very useful to some of our teams that I'm still responsible for. And I hope you can take a few lessons learned and maybe a few tools and practices out of this talk. Now, I'm standing out of my home office today. As you can see, I'm wearing a scarf, so I'm unfortunately not 100% fit. I hope my voice works for the next 45 minutes. Maybe I have a bit of a cough in between, but that should be okay. Nowadays, I'm managing director and CTO working for a company called Ivory. So headquarters in Munich, where Germany's greatest place to work right now in 2023. I've been working as a lecturer in software quality assurance here at the University of Applied Sciences in Rosenheim. And I kind of have like 25 years of experience in, software engineering, software architecture. I did my computer science degree back in '99. And since then, I've been in the industry and pretty much implementing digital products and projects since then. So if I finished 1999, you can assume that the primary, let's say, model of working and doing projects back then, there were like fixed price projects in a super unagile waterfall model, right? We had to write loads of documentation, from a rough concept, to a technical concept. And then at some point we started the implementation. So we had to write a lot of documentation, and architecture also looked pretty different back then. I mean, writing the documentation, I think we all thought that all the architectural decisions we made during that, concept phase, we kind of have 100% view on everything we have to build, on the technologies we use, what the technical architecture of the systems look like, what the infrastructure had to look like. So we had the assumption basically that everything we designed back then on the paper will work out once we implement it. Now we all know that obviously that didn't always work out that way, even though I think that you could implement architecturally sound systems even in a waterfall model. Now let's come to this ivory tower bit. I don't know if you exactly know what I mean with this, but usually back then in those old times, you always had a department who basically told you how to build the system, or basically they gave you constraints how you could build the system. And here's a little story for you. Maybe 10 years ago, team and we were responsible to build a search application, like search, document search. And nowadays, everyone thinks like, oh yeah, you'll probably have to use Elasticsearch for that one, or maybe Apache Solr. Now, back then, those technologies 10 years ago were not so widely known. And I had this argument for probably 6 months with one of those, ivory tower divisions that basically said, well, no, or you can't use Apache Solr, even though it was the correct technology to use. What they basically said is, well, you have to use Oracle database because this is our central storage thing, and we have a license for that. And you have to use Oracle. And we said, well, no, Oracle is really a suboptimal solution. It's really suboptimal technology to implement this system. So within these 6 months, basically what we had to do is we had to prove to them via, POCs and MVPs and whatever you call them, that Oracle is definitely suboptimal, and that we want to use something really new back then. Well, it wasn't really new. It was, I think, Apache Solr 3.6 at the time, that is the viable and sound solution to do and technology to use. And once we did that, and we wanted to start the implementation, the next thing we said is, well, we want to implement the system using Spring as a dependency injection framework. And guess what they said is, well, no, you can't use Spring because this is not a standard in this company here. So basically what they made us do is, or wanted to make us do is, that we would have had to use, what was that back then? J2EE 1.4. So really kind of, really old. All you had is like session beans and entity beans. And we wanted some more flexibility in the dependency injection. So basically what we then did is we kind of combined both technologies, which was really a sound thing to do, in my opinion. So we combined J2E 1.4 with the Spring framework. I think it was 2 point something back then. So really early version as well, to implement that system. And guess what? Again, I had kind of, huge discussion with that Ivory Tower enterprise architecture team, why we think this is, a viable technology and a viable solution. And obviously, we had good reason to do that, because not everything could be implemented with J2E back then, right? We had like standalone applications as well. Some parts of the application should not run on a container or on an app server. What we wanted is kind of a homogeneous, technology stack and framework and dependency injection framework back then. So we had good reason again to do that, but again, someone in the Ivory Tower who probably wrote his last line of code 10 years ago, kind of thought he could make the decision for us. Now, enough rant about these old days, right? I mean, obviously times have changed. Nowadays, we do everything agile, right? At some point, we had XP and Scrum coming up, the first agile models, popping up, trying to avoid all those, lengthy pitfalls we had from the waterfall model. So obviously, everyone was keen to adopt these things and to work in an iterative, short kind of term manner. You write some documentation, or you implement some parts, then you do kind of a retro, then you may adjust what you should do next. So a really flexible way of working. And don't get me wrong, I never want to go back to those old times, right? Agility is everywhere. It's kind of the standard right now, how you should develop large-scale systems. Now that manifesto was then, published, and it said something about individuals and interactions over processes and tools, working software over comprehensive documentation. So you should not write or need not write like 300 pages before you can start with the implementation. Customer collaboration over contract negotiation and responding to change over following a plan. Now that was the Agile Manifesto as it is today. Or back then, or it was back then, and everything's cool with all those 4 statements. Now, unfortunately, as it is with words, they can be misinterpreted. And I have seen many customer teams struggling with, let's say, the naive interpretation of that Agile Manifesto. So basically what they said is process and tools, well, not required. We don't need any standardization. Every team can do whatever it likes, okay? So everyone used his own tool. Maybe everyone applied his own, let's say, development or maybe, deployment processes, for example. Working software is key, yes, obviously. But what it led to is, well, why should we write any documentation as well, right? The code is enough documentation, as it states in the clean code book. So again, in my opinion, a misinterpretation. And well, that was not really following a plan anymore, right? It was like from sprint to sprint to sprint, we kept developing, or teams kept developing. That kind of led them downwards. So the end result of this misinterpretation, I think, was that here, it basically was, or is sometimes in certain teams, it's Wild West, right? I mean, it's great fun, don't get me wrong, it's great fun riding a horse. But from an architecture perspective, this Wild West architecture type, living and doing projects, unfortunately, this can very quickly spiral downwards, and will lead basically to this here. You end up with a lot of technical debt. You end up with an undefined, somewhat blurry software architecture. You end up with many teams doing different things, no standardization anymore at all, which is kind of a bad thing as well. So this is not where we actually wanted to end up with, right? We all wanted still, even though we develop Agile, we still wanted to have kind of a clean architecture, a sound and solid and maintainable and evolvable architecture that can be maintained and evolved over time very nicely. So that is one pitfall, but I've seen also the other pitfall. This is kind of going from one ivory tower to the other ivory tower, right? We had this one enterprise architecture ivory tower, and now suddenly I've seen teams that kind of went the total opposite direction into this, let's say, agile ivory tower, where teams had a really strong agile master, or whatever you would call them, scrum master maybe, that kind of did exactly the same what these enterprise architecture guys did. They said, no, it's 2 weeks, no matter if it works for you or not. You have to use JUnit as a unit test framework. I don't care what you like. So if you go the other direction and you have a real strong agile, whatever you call them, then that can quickly lead to kind of the opposite and circle back to where you came from. So you're now doing agile, but you're still not flexible, right? So these are those, cargo cult agilists. Let's call them that way. Now, okay, so what can we do about that? This is what this talk should be about, right? Now, I said before, a common misconception is that you don't have to write documentation anymore when you do Agile. And the contrary is the case, right? I can definitely not agree with this. You need some documentation, but obviously not this type of documentation you did like 20 years ago, 15 years ago, right? No one likes to write his documentation in Microsoft Word anymore. You need some lightweight, you need a code type thing. You need some format that you can version control in a Git repository, for example, like ASCII doc or Markdown, for example. And one really good and super lightweight and simple approach I have found, and many teams are nowadays using, is something called Arc42. Probably a few people of you in the audience know this format. So Arc42 is kind of, it's basically a template that you can also tailor if you like, if you want to leave out certain things. Those templates are available in different formats. You have like ASCII doc and Markdown, and you have Confluence format. So many different, very lightweight, modern, state-of-the-art document formats that still addresses many important quality and architecture aspects, and that need to be documented, especially in long-lived projects, right? I mean, I know every project starts really small, but I think the reality is, software is evolving constantly. And if you think of a, let's say, medium lifetime of a software system between 2 and 3 years, I definitely think it makes sense to document the 1 or 2 important, attributes of the system, right? What are the functional requirements and what are the fundamental requirements? What's the context of the system, right? Systems never live in isolation. They have external systems and interfaces they need to contact with, or they need to interact with, right? So this is something you should definitely document. Then the core ideas and solution approaches should be documented, right? I don't know, maybe this is architectural styles. Well, maybe we do Hexagon, we implemented with Spring. So all the technology things should be somehow here. So what's the general solution strategy to implement that system? What are the building blocks? What are the concepts of modularization taken within that system? What does the runtime view look like, right? How does the deployment view look like? I think this is important, right? Is it going to be containerized? Is it going to be serverless? Is it going to be run, I don't know, AWS native or within a Kubernetes cluster? So the required hardware and infrastructure and deployment stuff, that should be also documented. The next thing is cross-cutting concerns, right? What about security, authentication, the logging stuff and all that? Architecture has a lot to do with decisions. So architectural decisions should also be documented. Why did you take technology X in favor of Y? What are my quality attributes, right? What are my quality requirements? I see so many teams out there that have not documented their quality requirements. But how can you do software quality assurance if you have not documented the goals, if you have not documented where you want to go, right? Maybe some technical depths and maybe a glossary, right? If you do domain-driven design, this is called ubiquitous language. So please document the important nouns and verbs you're going to use. And now I talked about a lot of documentation, and maybe a few people already think like, oh my God, I'm back to the old days, writing 50 pages. No, not at all. Maybe if you do this here in a lightweight matter, then this is maybe, I don't know, 2 or 3 pages, A4 pages if you will print them out, right? So all you need here is, take those templates from the Arc42, web page, and then version control that stuff. And it's a few Markdown files, or maybe you choose to have a single Markdown file and version that documentation as part of the source code of your microservice. So you have no context switch, right? As a developer, if you do some changes, then the documentation is part of the same source code. You just open in your IDE a different file, you make the required changes, and that's it. Okay, this is all you have to do. So really not much work, I think, and it's worth investing in this very lightweight form of documentation. Okay, now I talked about this software quality bit, though, chapter 10 here in quality requirements. Now, I don't know, I know this is very outdated, always stating ISO 2510. I told you that I'm a lecturer for software quality assurance, so this is a kind of slide I took out of the lecture material. But if you take software product quality seriously, then this is a lot of work. This is a lot of work that needs to be addressed during implementation and also during quality assurance. But I think getting aware of all these, all these quality attributes is kind of important, because it will determine how much work you have to do in the certain area. So about security, I think we're 2023 now. Security is kind of it should not be an optional attribute anymore in modern digital systems. It should be mandatory and must be mandatory. You have to talk about authentication. Maybe I've thought about accountability, authorization, data integrity, confidentiality. This is things like, I don't know, you have to use TLS if you talk to another system. You have to use encryption at rest if you store data on some disk or some database, for example. You want a user to log into a system and only do execute the use cases that he should use or that are kind of associated with his role. So security, super important. Functional suitability, obviously. Obviously, you need to be complete, you need to be correct, and the use cases should be appropriate. You need to build the right system. You need to make sure that you build the right system. So you need some form of acceptance tests, probably, right? And with the security, you need some form of penetration tests, maybe. Usability. Obviously, we want to build shiny web front ends with a good user experience. So we have to make sure about that. Efficiency. Yes, we're in the cloud, and technically we have all the resources available we want, but we want to make sure that the timing behavior is correct, that the resource utilization is as low as possible, from a sustainability point of view, also from a cost perspective. What's the required capacity of my infrastructure? Reliability. We want to build reliable systems, so they should be, I don't know, 99.9 available. We want fault tolerance. We want recoverability. So maybe you have to think about, hot cold standby things, circuit breaking things. All these things need to, influence, or those quality attributes influence how we build the system and how we run the system later on. Maintainability. This is what we software engineers always think about: modular and testable, modifiable. These good old things. Compatibility, maybe, we're in a REST world, we have different systems talking to each other via some API, so we need to make sure that we don't introduce any breaking changes, so maybe we need to do some contract testing here, and also portability. So you see, deciding on which of these attributes are important is crucial for our test strategy later on, and is also crucial for certain decisions we take while we implement things and when we operate things. So please make sure that you talk to your product owner which ones are the one important. Now, having said that, the unfortunate bit is that the product owner is not the only stakeholder. And I want to introduce it to another. This is kind of the sister of the ARC42. There is now a new quality model that has been released quite recently, which is called Q42. Now, the thing is, if you talk to your stakeholders about reliability, the thing is, or the reality is, that everyone understands a bit of a different thing, or maintainability, or maybe usable, right? So if you use these words and you talk to different stakeholders, like your product owner, like your ops team, or your SAE teams, or your testers, or your domain expert, or your end users, possibly, each and every one of those stakeholders understands slightly a different thing between those systems, right? What is operable, right? Operable from an end user perspective is what needs to be super easy and super self-explaining to use the system. This is the end user perspective. And operable from an admin perspective is I want an admin front end, or I want to be able to diagnose the system when there's an incident. I want to diagnose the system very easily. So have a look at Q42 as another simple, pragmatic approach, how you can determine and then document these quality attributes and quality features which are most important to the system. Okay, obviously you can document everything, but that is then a time and obviously a budget issue. So decide on a 1 to 3 or maybe 1 to 5 most important quality attributes, focus on them. Not everything can be equally important, right? Software architecture has a lot to do with trade-offs, deciding what is more important than what, and then focus on these most important quality attributes and document them. So from all the talking now, the thing is that all these required quality attributes that you decide on, they can be found on all the layers of your software architecture. Obviously, when we techies or architects think about software architecture, then obviously we often think about what I call technical architecture. Typical inputs are, the non-functional requirements, maybe some enterprise standards, maybe a reference architecture, and that kind of outputs. If you apply these, then the output of designing this technical architecture, maybe what type of, what architecture style do you want to apply this to the system? Do you want to use layers? Do you want to use onion architecture, hexagonal architecture? What are the technical components that I'm going to use? Maybe I'm going to use Hibernate as a persistence framework. I'm going to use Spring as the dependency framework, or maybe you go even bigger, like you want to use Quarkus as the overall framework to implement your services. Which other third-party open source dependencies are you going to use? So this is what I call the technical architecture. And many of these attributes kind of influence the decision on these things. Other views, and I would argue that functional attributes are also found on these views, is kind of the conceptual view on an architecture and also the infrastructure view on an architecture, right? So I said it before, if reliability is super important, then obviously your architecture as well, your infrastructure architecture as well, obviously needs to address these kind of always called non-functional requirements. What type of hardware am I using? How do I do, I don't know, we're in the cloud, and how many availability zones do I have to deploy my application to be highly reliable? So what kind of software infrastructure do I have? What type of protocols do I use? How do I handle storage and networking and compute and all that? And also on a conceptual level, I think quality attributes is also apply, because on the conceptual level, you think about the data models, you think about the use cases and also functional requirements. And that influences those, the domain boundaries. If you're in a domain-driven world, the conceptual architecture pretty much describes what is the system context, what are the interfaces to surrounding systems, what is my business domain made of, and what domain model do I need to use and need to implement to address these attributes. So think in different layers and try, and this is, again, unfortunately, this is worth noting down and documenting in a lightweight manner. Where can these quality attributes be found, and how to address these in the different layers? All right, now you might think, enough of documentation. Well, okay, maybe we stop with the documentation and come to fancy diagrams and fancy drawings obviously your documentation hopefully has some form of diagrams in them, right? I mean, a picture, what we say in Germany, a picture says more than 1,000 words, right? A good diagram expresses a lot of stuff. Now, unfortunately, if you look at different teams, I've seen a great talk by Simon Brown, and what I show you is kind of taken out of what he kind of promotes in the world. If you ask a team, here's a whiteboard, please draw me the conceptual architecture of the system, then it will usually get a picture, but it's a total mess. It kind of messes up those different views. It messes up conceptual things and artifacts with technical artifacts and infrastructure artifacts, and then you have like random errors showing around, and these are not good diagrams. So it's also worth thinking about how we could implement a lightweight form of diagrams. And the one thing that I have found the most useful, and definitely our teams have also found the most useful, is a concept called diagrams as code, right? We want to be close to a source code. If you change something in the source code, that might have an influence on the diagrams. And what Simon Brown and the Structurizer project promotes is something called the C4 way of drawing diagrams. So the C4 stands for context, container, component, and code. Now, as you all know, you cannot put each and every detail into a diagram or into an image or into a drawing, right? This has something to do with how a human brain works, and the human brain has difficulties once you have more than 7 different things in a diagram, like colors and boxes and lines and shapes. So you should not go beyond that magical number of 7. Otherwise, the diagram is really hard to digest and really hard to comprehend. And that is why they proposed the context, container, component, and code approach, where code is optional. Now think of maps, right? Think of maps. You have the global map, and then you kind of do a double click, and then you can drill down to a country, and from a country you can drill down to maybe cities and roads and even further. And that is what that is here. So this is kind of this is called the context diagram. So context is really what's the system context of the system. There's a system, these are the neighboring systems, I have following users. This is how we interact with other systems using some APIs. So this is like really the I don't know, the 50-kilometer height view on your system and on your system landscape. And now imagine you would double click on the system context, then you would drill down into container, into the next level, which is called container. And please, container is kind of, I know it's a bit ubiquitous here, but don't think please of Docker container, right? Think of container as some generic thing. So container can be a database, a container can be a subsystem, so this is what's called container now. So you double click on your system context, on the system you want to build, and then you come into the container perspective. And there you then have the database. There you have 1 or 2 or 3 maybe microservices, which are then the container. And obviously the external systems are also containers. And if you now do a double click on one of these containers, you then come down to the component level. And component is really now we talk about conceptual business type components, right? Some controller, some, I don't know, let's say persistence unit maybe. So this is what's called component. And if you would then double click on a component, then at some point you would go to the code level, where we really talk about interfaces and classes and enums and whatever you have as to implement your system. So usually you can skip the code view, because at that point you can easily go into a code base and have a look yourself. So what you should aim for is that at least the components, they have kind of some logical representation in the code, maybe as a package or maybe as a jar module you have in your build system or something. So if you kind of map the component view onto your source code, then that should be the most obvious way of navigating between these things. And the nice thing is with C4 is you can either write Java code or whatever code you like, to kind of draw these diagrams. So this makes it really refactoring safe as part of the code base, or you can use some high-level DSL to kind of achieve the same thing. So please draw diagrams that are easy to digest and put them into your documentation. Now, I talked about decisions before. Architecture has a lot to do with decisions. Do I should use Oracle or Apache Solr? Should I use Quarkus or Spring? Things like this, right? So decisions, left or right. And usually it's not only binary, left or right. You usually have like, I don't know, maybe 5 possible solutions. Should I use a graph database, a relational database, a document database, or some, I don't know, time series database? Now, the thing is with decisions is, how do you take them? How do you document them? And when do you do them? And a concept I've learned from a talk from Neil Ford from ThoughtWorks was the term of, well, the last responsible moment. And mind the wording, okay? The last responsible moment is unequal to the last possible moment, okay? And really take decisions at the last responsible moment and not the last possible moment, okay? So this is what you should aim for, responsibility. We want to make decisions responsibly. Now, the thing is, or the basic idea is, well, that's kind of easy. The longer you wait, the more knowledge and context you have. So the longer you wait and the more context you have, the better you can take the architecture decision. Now, when do I know when the last responsible moment is? That's the big question. And I kind of have here a few useful questions maybe, which you can always ask yourself, well, do I have to take this decision right now? And what happens if I don't? Can we postpone the decision? And what are the consequences of postponing the decision? If you postpone things, then obviously you work the way you did work like the sprints before. So maybe a good KPI would be, when is the overall complexity of my system or the module system or the build system or wherever you have to take that decision, when is the overall complexity too high? When do I take too many technical depths that will make maintenance a nightmare? And then maybe it's time to take that last responsible decision. Do you have alternatives? And I hope you do have alternatives. I mean, if you don't have alternatives, you don't have to make a decision anyway, right? Then you're out of options, and then you have to take that one options you have. So that's not really a decision; that's forced. What are the trade-offs of your decisions if you take, right? If you have alternatives, you can do kind of a trade-off analysis, an architecture trade-off analysis that should hopefully help you in taking that decision, that responsible decision. And obviously, how can we revert a decision? It's always good to have a fallback plan. And how costly is it to take that decision? Now, that sounds awfully maybe complicated or scary. I would recommend, have no fear of suboptimal decisions. I think if you, apply good engineering practices, the decision you will take at, moment X should be pretty optimal. And yes, maybe 3 months later, you find out that 3 months before the decision was not good, but at the time you did the right decision, right? And things change. Afterwards, you're always smarter. So be brave, okay? Don't push decisions too long. And if you do proper agile iterative development, and if you do test-driven development, and if you apply refactorings and continuous integration and deployment, and apply architecture fitness functions, and I will show you later, then this will definitely help to reduce the risks involved in taking a decision. Okay, so don't fear decisions, just make them properly and document them. So that's the next bit. Now, Michael Nygaard back in 2011 introduced basically the dilemma of taking architecture decisions in an agile project. Remember, we don't have like big upfront design and big upfront documents anymore. So what will happen is that not each and every important decision is known at the start. You will not take each and every decision at the start of the project. So you have to document them. Otherwise, two things might happen. If you don't document them, then either you miss the opportunity to improve the system because the next person coming to your team will basically blindly accept the decision, or which probably even worse is, if a new team member comes on your project and it sees like, ooh, they use a relational database here, ooh, I don't like relational databases, I just blindly change the system, then that can go wrong, most probably will go wrong, or maybe it's right. But be aware of those two. So either way is not optimal, right? Blindly accepting this decision is not good. Blindly changing it is also not good. So what he proposed is something called an architecture decision record. So again, a lightweight form to capture important architectural decisions along with their context and consequences, okay? What was the context of the decision? What were the alternatives, and what are the consequences? And again, simple Markdown file, if you like, or put it into your Arc42 documentation as part of the Markdown documentation. Should not be longer than 1 or 2 pages, right? You can do it in Markdown, ASCII doc, plain text, Confluence, whatever you like. Give your architecture decision a number and a suitable name, like AWS is our preferred cloud provider. Then give some context. What are the forces at play? Maybe political things, project local things that need to be taken into account. Maybe there still is some enterprise governance board. Maybe these forces are at play surrounding technology that may be in place. Then state your decision. We will use AWS. Then usually those architecture decision records, they have a status: proposed, accepted, deprecated, superseded. So obviously 3 months later, you might decide, no, it's not AWS anymore, it's Azure, because of the following reasons. And obviously state the consequences, right? So if you say AWS is the preferred cloud provider, then obviously a consequence is that everyone on your team should be kind of versed and capable of, knowing the AWS universe. Now, having all that, another good thing is something called an architecture fitness function. Because if you have all these different quality attributes and you think of a large system with not one Agile team, maybe you are the architect responsible for a huge system, for a large system, and you have like 5, 6, 7 teams that kind of implement all that. So having that large scale setting, it's pretty easy to lose track of all these KPIs and all these metrics and all these dashboards you have. So how can we, assess the architectural and quality characteristics of the whole team and verify the criteria? Such as, unit testing, metrics, monitoring, security attributes, whatever you think of. So we want to continuously validate those characteristics, those quality characteristics of our system. So this leads us to a new way of how you can do, fitness function-driven development. So think of architecture like as a product with user journeys. So at the beginning, you should, collect all those requirements from the business, compliance, operations, security, and infrastructure from your stakeholders. This is what you should have done anyway. These are usually those entities and quality attributes. And what you then do is you formulate acceptance criteria using a behavior-driven approach. I expect that my test code coverage is always above 80%. Or given the code quality, when I measure, then I want 80% coverage. Like this would be the formal behavior-driven approach. So given when then. And all you do then is, once you've codified these, these checks and validations, you just integrate them into your CI workflow, or maybe as a nightly job that continuously validates these requirements. So this is what code quality might look like. I expect that my test coverage is above 90%. Or the maintainability rating I have in Zone R is kind of below 0.1 or a higher B. Maybe performance. If you do performance tests regularly, then obviously you can check each and every time you run the performance test, you can continuously also check, is my transaction round trip time below 10 seconds? Or do I have a low error rate? So I always see this is kind of the same thing. This is now in a Ruby syntax, but you could use any behavior-driven framework you like. Security is the same. I want no secrets in my code base. I want to have no OWASP top 10 vulnerabilities. I don't want to have any vulnerable dependencies in my code base. Things like this. Operability as well. Okay, do I have a runbook? Do I have a README? Have I defined any alerts? Have I defined and documented my trace IDs? So this is totally up to you which one of these KPIs are more important or not. Now, you might think, ooh, that sounds kind of difficult. And unfortunately, there's not a open source framework I can really recommend that does all of this. But what you need is a single source of truth. And basically, if you look at KPIs, this is nothing else than a time series in a way. So you might use InfluxDB, or you might use TimescaleDB or something like that. And all you need is something called maybe Grafana to implement nice dashboards. So this is kind of the overall architecture, and have a look at the bottom left. This is where what I call the quality cockpit is. Into this single source of truth, everything you do during your software development lifecycle, all these measurements, all these KPIs, they all end up in this quality dashboard in the same InfluxDB. So the build status, the code quality, the test results, the findings, the security findings of scanning your Docker container, the deployments using Argo Flux, were they successful? Maybe you have some integration tests and performance tests and penetration tests running on your infrastructure, on your Kubernetes cluster. So everything should be kind of integrated into that quality cockpit. Then you can implement your architecture fitness functions against this time series database to have like the decision, am I safe to release or not? This is usually what your product owner will ask you. Can we deploy tomorrow? Is everything okay? And once you do that, you can maybe implement some automatic promotion as well. If the system is green and you meet all your quality attributes, then basically you can also implement some form of automatism that promotes, from int to QA to prod or whatever, based on the quality requirements, and not some vague, guessing of some architect. Yeah, I think we're safe to release. Now, if we talk about architecture, obviously have that term clean architecture usually. And trust me, humans make errors. And if you don't have measures in place, it's super easy to go from your clean onion architecture to that big ball of the mud on the right-hand side. So this is some example of how you can implement architecture fitness functions for your architecture, for example. I'm sure you all heard of ArcUnit. If not, then have a look at it. It's kind of an easy way how you can codify the software architecture rules and verify them using a plain unit test. So it's a cool open source library, and you can, codify rules for common architectures, layered, onion, hexagon. You can find cycles between classes and packages very easy. You can enforce good coding practices on naming and logging, for example. You can even validate a code base against a plant UML diagram. How should my system look like? And if it, and that test will fail if some commit fails to comply with that architecture model. So this is what it looks like in Java, for example. Okay, so that's, I don't know, what is that? 15 lines of code, bit more. I left out the imports, for example. So maybe it's 20 lines of Java code that are super easy to write and that help you to continuously and repeatedly verify your architecture. I'm not sure if that German saying translates that way. Where wood is chopped, splinters must fall. So that is a German saying, I know. So obviously, we make mistakes, and sometimes we knowingly make not bad decisions, but we knowingly take the easy route. And what that will lead to is usually what we call technical debt or domain level debt. And you need a way to address this. And that's kind of the last bit. So there's another brother of, Arc42 and Q42, which is called AIM42. And this is kind of a structured agile process how you can tackle technical debt. And what they say is regularly analyze the technical debt of the system, document them, find the issues, find the risk, interview stakeholder, analyze the architecture and code. Then in a second step, you should evaluate the findings and estimate the costs and the value of an improvement. Don't improve it yet. Then based on those evaluations, do kind of a trade-off analysis and take a decision. And once you're taking the decision, you can then, in the third phase, continuously improve the system, improve the code, improve the technology, improve some technical concepts, and then integrate with your normal, 2-week, 3-week sprint iteration. So this is a lot of stuff. Now you have to know in your brain, and that leads to cognitive load, unfortunately. A lot of extraneous cognitive load, okay? So younger teams, junior teams can easily be kind of overwhelmed with all these architecture work they have to do. What I would suggest is, I mean, collaboration is key here, okay? So software architecture should be defined and worked on in all teams and all layers. So what we usually do is we have a dedicated enabling team that helps kind of those streamlined teams to take the right decisions. This enabling team makes sure that we kind of have kind of a sound, kind of homogene technology stack so that the streamlined teams can work on, you know, and collaboratively work on different systems as a part of the system. So think about how you let's say, instantiate architecture work within your project or in your team. But having a dedicated enabling team, for example, that kind of has one architect on each of the teams and that they, I don't know, exchange architecture ideas every week has proven to be like a lightweight and super easy way to go. Okay, so this is almost the end. Hey, this was just a brief overview of different things that I think have proven to be really valuable in the systems I'm responsible for. There's a lot of cool, you know, books and material out there. I'm really a big fan of these 4 at the moment. So fundamentals of software architecture, building evolutionary architectures, architecture metrics, and the last one. So these are really 4 books that I think should be in your bookshelf and are definitely worth reading. All right. That was it. Thanks for listening, and let's see if there are any questions.
Yeah, so thank you very much for your interesting insight on this presentation. Yeah, if there are any further questions, you can just unmute yourself or just write a message in the chat. I'm not sure, Mario-Leander, if you can see the chat already to...
Yeah, sometimes the chat disappeared.
Okay.
when I switched to the screen share.
There was just a question if it's possible to get the slides somehow. I'm not sure if you can just like, if you want to provide them.
Yeah. Obviously,
Yeah.
I will provide them. Usually what I do is I upload them to Speaker Deck. This is where all my presentations are. So you give me a quarter of an hour. Then I've uploaded them to there. And obviously you can follow me on Twitter or maybe LinkedIn, and where we'll then post the link. So yes, they will be made available. Absolutely.